everyone. So this is from exercise 2F, and it's question 5 on exercise 2F, which was the coding part of the chapter. Just had a question just to clarify how we work this stuff out. So here we have, I'm going to do parts A and B, and then C is about the standard deviation, so we'll look at that separately. This is the frequency table that we're given in the question, and we're also given a coding equation. And the whole point of coding is to make our answers a little bit neater and easier to manipulate. I've also got my calculator here, so what we can do is we can start off with the cheat method of how we work this out, and it's good to practice this getting in and out of statistics mode. So what we need on the calculator, and this is on the video that I think I've sent, we go into setup mode, so just one press on this button, mode setup, or menu setup, and then we're going for option 6, which is statistics, and we're just dealing with one variable here, x, so it's number 1 on that list. This might not be very clear on my calculator because of the light here, but what you should get is a little chart, seeing if I've got that right, with x and its frequencies to put in. If you're not in frequency mode, have a look at the video to check out how to get into frequency mode. But you should see 2 columns, x and frequencies. And then we can just put in the corresponding values. Now, this is where we come back to the chart that I've got here, because when we've got a chart like this, it's tempting to think we can pull all the answers out straight away. But actually, what we need is a whole load of more rows in here. And the first one is the midpoint, because the midpoint's what we're going to use as our x. We're not going to use these ranges because we can't put them into the calculator. So the point of a midpoint is, well, it's easy enough to work out. We're going to get 21 here because it's halfway between 20 and 22. And this is continuous data, so it goes right up to 22. And then the next one starts at 22 and a little bit. So we use these midpoints, and it's basically because when we've got this continuous data, some information has been lost here. We don't know whether we had these 3 light bulbs that we put into this category. We don't know whether they were up near the 20-hour end or were they all at the 22-hour end. We've lost that information when we took these figures. So we've got 40 bulbs in there, but were they near 25, were they near 24, 26? We don't know what the spread is, so we've lost some information. But what we're going to assume is that the average of those 3 is 21. We're going to assume the average, or the mean of those ones, was 23, halfway between the limits. So the midpoints are us just assuming, and again this is a big part of linear interpolation as well, is how is this data spread out across a range or across a class interval, and we're just assuming it's spread evenly. So the midpoints are what we're going to use. Now if we were going straight to find the mean, what we could do is we could multiply these. So the mean is, mean is just the sum of all those x's. So we've got 3 lots of 21, so it's x, this is our new x, times f. So we multiply these, 3 times 21, 12 times 23. We could have this xf range in here. We'd get 63. Some of these are easier than others, 1,000 in there, 270, something like that. And we would add those all together to find the total number of hours that all of these light bulbs together have given us. And then we would have to divide it by the total number of light bulbs. So another thing that's useful when you're doing these charts is to add a column at the end. Might be the whole thing's up the other way, so it might be a row or a column. And this is our totals column. So if we add all the frequencies together, we usually call this N. So we usually give that an N. That's the number of light bulbs in this case we've got. So we add those together. It says in the question actually that it's add up to 70. So we should add up to 70. When we add all of these X's together, that doesn't actually give us a very useful result because they need to be weighted by their frequency. But when we add these ones together, we should get XF, the sum of all the light bulb hours that we've got. And of course the mean, I'm not quite finished with that, still needs to be divided by N, or the sum of the frequencies. So these little sigma signs just tell us that it's a total. We know N is the total number of light bulbs, but if you see a sigma F, it's the same thing. It's the sum of all the frequencies. Okay, so that would be how we would find out the mean. We'd add all of these together, we'd get a figure in here for the sum, and then we'd divide it by 70. But we've been asked to find this Y instead. So coding is all about, we can see some of these numbers are getting quite big, and coding's all about making them more manageable, a bit easier on your calculator. So what we do is we try and work out what the Y value would be. Now this midpoint is what we're taking as our X. We're no longer going to worry about that top row. And so our Y value, if we work those out, 21, if I put 21 as my X in here, I get 21 minus 1 is 20, over 20, I just get 1. So we just work these out, just in green. We just work these out according to this formula. If I take one off that, 22 over 20, this one ends up 24 over 20. Okay, I can see what they've done here. Yeah. So we can work out those Y values just by coding these midpoints, which is now X's that we're using. Okay, so we've got these. And then if we were going to find this mean, of course, again, we need yet another column because we don't just want to add these together. We don't want to find that result as equally unuseful. We need to multiply them, weight them by their frequencies, and get them to work out that way. Just take that light off the board. Okay, so I'm going to do another column, which is going to be Y times F. And that's going to be our part A, is we are going to do the sum. So we're going to find Y, the mean of Y, is going to be the sum of all the Y's times their frequencies. So this times 3 gives me 3. 1.1 times 12. Oh, someone can work that out. 4.8. Oh, 48, sorry. 48. 1.3 times 10, 13. Well, that's 7. I'll work that one out eventually. But we can add all these together. This is our sum of Y times F. So this is going to be part of our mean. And then we just divide it by the sum of the frequencies, or N. So N is the sum of the frequencies. So we know N's 70, and we can add all these together, get whatever total is in here, and divide it by N. I don't think, no, I don't know if I've written down for that one. 1.1 times 12, how hard can that be? It's a 12 plus a 1.2, so 13, 13.2. Okay, so we would add all those together. We get 20 68, 70, 71, 81, 84.2. So 84.2. So this is now 84.2 over 70. And we can stick that in the calculator just in normal mode. So shift 1 will get you very used to changing modes on calculators. 84.2 divided by 70. It's actually got a few more digits than this. Mine goes to there. But obviously we would round. But great idea to leave that on your calculator so that you're not rounding at this stage. Because when we work out B, when we're finding B, it might be that we need to magnify this answer. And in this case we do. So remember our relationship between x and y. For the mean, we have to do both of those transformations. We've got to take one off the x and we've got to divide it by 20. So I can rearrange that and say that, so this is true for the mean as well, for coding, and I'm just going to rearrange that to get x the subject. So I'm going to multiply by 20 and then add 1. So if this is my y hat, or mean for y, what I need to do is multiply it by 20, and this is where all those decimal places might become more significant. So we just multiply it by 20, and then we need to add 1. And my answer is that x bar, mean of x, 25.057 something, something, something. So that 2 there has actually become quite significant. So we don't want to round too early with this. Okay, so those are the means, and it's much easier if you've done the mean using coding, much easier to not have to work it out again and do all these multiplications. Much easier just to uncode it using the relationship between x and y. So for the last bit, I'll do a second video just looking at the standard deviation.